Next question, question 37. Consider a 3-digit number. Question, what is the number? Statement 1, the sum of the digits of the number is equal to the product of the digits. Statement 2, the number is divisible by the sum of the digits of the number. Which one of the following is correct in respect of the above question and statements? A, the question can be answered by using one of the statements alone but cannot be answered by using other statement alone. B, the question can be answered by using either statement alone. C, the question can be answered by using both the statements together but cannot be answered using either statement alone. D, the question cannot be answered even by using both the statements together. So we will see, it is given it is a 3-digit number. Now the sum of the digits of the number is equal to the product of the digits. Let's say the number is x, y, z. So that means x plus y plus z is equal to x into y into z. So x into y into z. That is the first statement. So we can think of a lot of numbers like this. So first statement alone will not be able to decode the number. So let's look at the statement 2. Statement 2 says the number is divisible by the sum of the digits of the number. So let sum of the digits of the number be, let x plus y plus z is equal to k. That implies the number xyz is k into some n. So n be any positive integer. So our number is in this form. So this is the statement 2. So even here, number is divisible by the sum of the digits of the number. If you take that alone, let's see whether statement 2 alone can help us find the number. So the number is divisible by the digits. So let's say let's think about different sums. So even in first statement 1 and statement 2, sum is there, sum of digits is there. So sum of digits cannot be what is the minimum sum that this 3-digit number will have? The minimum sum, can it be 2? So is it given that all the 3 digits are unique? No. So if 2 is only given, statement the number is divisible by the sum of the digits of the number. So so let's think. So x plus y z, the sum x plus y z can be 1. So can it be 1? So if it is 1, we will have plenty of numbers. So any number x, y, z will be divisible by 1. So if the sum is 1, we will have multiple numbers. Just think about any number, and how can x, y, z be 1? It's only when it's like x is 1, y and 0, y and z are 0. In only this case, we will have a 3-digit number and sum as 1. So as you can see, 100 is divisible by the sum of the digits, that is 1. So we can think of any number and so this is the only number that we can it gets divisible. So if the sum is 1, we will get the number as 100. There is no other 3-digit number with sum of the digit as 1. So that is one case. So let's think about the second case, x plus y is equal to 2. So in this case, there are multiple numbers, but let's think 200 is one possibility. 200 is divisible by 2, that is one possibility, and 101 is not divisible by 2. So any number other than, so even when sum is equal to 2, the number we get, we will get the number as 200. So here, as you can see, if 2 alone was given, Whether it is 100 or 200, we cannot know. So statement 2 alone will not be we will not be able to answer what is the number using statement 2 alone. So we have already got two possibilities, 100 and 200, for when the sum is 1 and sum is 2. So we can check all other sums and we will get multiple other options. So statement 2 alone will not help us to find the number. So now we will think about statement 1 and 2 together. We'll see whether statement 1 and 2 together will help us to find the number. So when we think x plus y is equal to x, y, z, whether sum can different sum, whether x plus y z can be 1. No, since if when 1 and 2 are together, if sum is 1, that implies x into y into z is equal to 1. The only possibility is 1 1 1, x y z to have 1 1 1. So in that case, sum will be 3. X plus y plus z will be 3. So sum cannot be 1. There is no such case. Similarly, it cannot be 2. If sum is equal to x, y, z, the only possibility will be 2 into 1 into 1. Again, sum cannot be 2. So 2 is also not possible. 3. Again, 3 is not possible. So only possibility is 3 into 1 into 1. So even here, we will have sum as 5, so that is not possible. So sum is equal to 4. Sum is equal to 4. In that case, we will have 4 into 1 into 1 as one option. That again sum will be 6, so that is not there. So 2 into 2 into 1, so again sum will be 5. That is not also possible. So even 4 sum is not acceptable. So let's think about sum 5. When 5, the only factorization possible is 5 into 1 into 1. Again sum is 7, so even that is not possible. Now let's see sum 6. So here the factorization of 6 is 3 into 2 into 1. As you can see, sum of sum is 6. Sum of these are 3 plus 2 plus 1 is 4 5 6. So this is possible. This sum is possible. So when 1 and 2 are true, 3 2 into 1 is possible. So that means we can think we will think about the numbers that we can make with 3 2 and 1 as x y z. So x and y z can take any value from this. So total possibilities will be 1 2 3, 1 3 2, 2 3 1, 2 1 3, 3 1 2, 3 3 2 1. So these are the numbers that we can make with 1 2 and 3. So as you can see, in all these cases, sum of the digits will be 6. Now we have to pick the numbers where this number will be itself divisible by 6. So sum of the digits in all these cases is 6. And product and that sum is equal to the product of the digits also. So statement 1 is satisfied in all these cases, and let's see whether statement 2 satisfies for any of these numbers. So as so for that statement 2 to be true, the number has to be divisible by 6. So to check the divisibility by 6, we know that we should check it should satisfy the divisibility by 3 and 2. So the number has to be divisible by 3 and 2. So to check the divisibility by 3, the sum of the digits should be divisible by 3. So as you can see, all these numbers, the sum is 6 and that is divisible by 3. So all these numbers are divisible by 3. And now let's see which numbers are divisible by 2. So ones ending with 2 are divisible by 2. So 132 is divisible by 2 and 312 is divisible by 2. So as you can see, that implies if you take 132 and 312, it satisfies, these two numbers satisfy both statement 1 and statement 2. That is, statement 1 is what? X plus y plus z. X plus y plus z is equal to x into y into z. So as you can see, 1 plus 3 plus 2 is 6. 1 into 3 into 2 is also 6. So statement 1 is satisfied in both these cases. And statement 2 is what? Statement 2 is x plus y plus z is the number is itself divisible by 6. As we have seen, we selected these two numbers which passes the divisibility test by 6. So 132 and 312 are both divisible by 6. So statement 2 is also satisfied. And as you can see, even after using statement 1 and statement 2, we are not able to arrive at a single answer. Both 132 and 312 satisfies these two situations. So we will not be able to find the answer using statement 1 and 2. That is what this means. So we only took sum as 6. We could have checked some 7, some 8 and all, but but even when we check for sum 6 itself, we are getting two potential answers that satisfy statement 1 and 2. So that itself makes it clear that the statement 1 and 2 together, even if we use it together, we will not be able to find the number. So the answer will be D. The question cannot be answered even by using both the statements together. So solution to question 37 is D. An example is this. Using this example, we can show statement 1 and 2 together cannot help us to find the number. So solution to question 37 is D.